Hello guys, so welcome to the cold weather in Han River. The air today is pretty nice, so it wouldn't be you get to enjoy the clear sky. Okay, so this is my New Year's resolution to come to the field and talk about a little bit of techniques for AA or AI math. And today I have prepared some of the trigonometry for AA students. So without further ado, let's get started. Okay, so I have some series of problems, so I don't know if I can actually manage to go all of them because it's so cold. But yeah, let's have a look. So let's have a look at the problem like this. What I want to talk about here is not like how to what the solution is, but how I'm going to approach on the on the student's shoes, right? So when I see this problem, what I want you to notice, oh, okay, this is a triangle. And if you're dealing with triangle, there are many restrictions, isn't it? Because there can be restriction with the angle that the some of the interior angles has to be pi, or if it's a non-right triangle, we often deal with a lot of a sine rule or cosine rule. Do you agree? Yeah, there you go. So, when I look at this, what I want to do here is to realize that this is a case of what? You're absolutely right. This is gonna be SSS case, and whenever we see SSS case, we know that we're gonna deal with the cosine rule. So I'm sure, even if the question doesn't tell me that it deals with the cosine rule, that I will get to deal with the cosine rule. So that's very important, isn't it? So realizing that I'm gonna use a cosine rule, even though the question doesn't tell you to use, is very important, right? So that's what the deductive thinking is. You need to decode the hints and clues in the problem into the formula or theorem that you know of and use them quickly, right? So that's what's expected for the AA. Okay, so I'm gonna use cosine rule because it's a case of SSS. That's lovely, but I think for part A, what you had to show is that this will be the longest side. So for that one, what you would do is to use the triangle inequality, right? So we do know the sum of the sum of the two smaller sides must exceed the sum of the large the remaining largest. So if you want to show that this has to be the longest, then what you can show is attempt. So you can try to see the size difference between the n squared plus n plus 1 versus sum of the other two, which is going to be 2n plus 1, and then the n squared minus 1. Those two we're going to see together and see which one is going to be bigger. So that is going to induce the triangle inequality. And for part B, yeah, sure, show that the largest angle. So if I have a triangle, I'm just going to randomly draw, sketch a triangle. It doesn't have to be obtuse, doesn't have to be acute, but for our convenience, I'm gonna draw acute angle triangle. And I'm going to claim that this is the largest, and I'm going to give the theta to be the opposite angle. And we do know that it's going to be 2n plus 1 and then the n squared minus 1. Capiche? And for that one, what we want to do is to use the cosine root. So I'm going to use the cosine root for the SSS. It's going to be cosine theta is equal to, it's going to be, what is it, the 2n plus 1 squared plus n squared minus 1 squared minus, boom, boom, wow, is what we have, isn't it? And then 2 times 2n plus 1 and n squared minus 4. But here's the thing, whenever we have a question like this, it's great that we have what is it, the aim. The aim here is to show that the opposite angle, I want it to be 120. So what you are actually going to end up showing here is, after a lot of simplification, that this is going to become negative half, right? Because we know cosine 120 degree by the reference angle, right? We are ascending into the second quadrant, and then that makes it, what is it, the negative cosine 60. So we know that it's gonna be negative half, and that's the aim, isn't it? Because one of the show that problem, you already know the answer. So what you're trying to do is to try your best for the algebra to get to the answer. So I want you to realize that I'm not solving this extensively, but rather talk about what sort of clues or hints we need to do when we solve problem. Oh my god, it's so cold, my cheek is freezing. Oh, okay, I didn't realize that. Okay, so but please understand if it's visible. But anyways, let's have a look at the next questions. Yeah, like things like that, things like this. I think this is also a very nice problem dealing with the triangle. But here's the thing, I don't want you to jump into the problem, but utilize your reading time well. When I look at this question, what I recognize is, hold on a sec, I have x and x, so I got the 2x there, isn't it? So I can probably end up using 1. I got the same multiple of x, 2x, and that tells me that it might deal with the double angle, isn't it? So what I mean by that is, from the inspection, I can tell that I can use first of all, the adjacent, and then the hypotenuse. Maybe you can do with, what is it, the cosine 2x. So that's gonna give you what? The 6 over 10. Right, that's great. And I want to find the exact length of BD, where BD, I'm going to call it Y. Okay, so you are given cosine 2x, and what you're trying to do is to get the, what is it? A cosine x is going to be 6 over y. So your y is going to be, what is it? 6 over cosine x. So if I can get the clue about the cosine x, I'll be able to solve it. And yes, I'm going to use the double angle of the cosine 2x. But here's the thing, this is also a very nice problem because it asks you to use the double angle of the cosine. Well, how many forms of a double angle do we have? You're absolutely right. We have 3 forms of a double angle of a cosine. One with the sine cosine, one just in terms of sine, one just in terms of cosine. And it depends on the types of equation, which one you need to use. And for this one, which one would you like to use out of those 3 forms? You're absolutely right. What I'm going to be interested in is to actually use the one just in terms of cosine, because I got to use the cosine here, you see. So that's how you get to choose the double angle of cosine. So for me, I'm going to use the 2 cosine squared x minus 1 and 6 over 10. And oh, hold on a sec. So that's very lovely, because I'll be able to get the cosine x value. And then I can simply just substitute in. So when you look at the problem, the first half is that you know your tactics. You must be able to find the clue. The first problem was about the triangle, so I wasn't ready to use either sine or cosine rule. It was SSS, so I was inclined to use the cosine rule. And the second question here, I see I'm looking at a triangle. That's lovely. It's a right angle triangle, so very likely to use a SOHCAHTOA. And here, obviously, we're going to use cosine. And I see the same x twice, so that tells me that I must be using the double angle of the cosine. You see, so those are the things that you need to practice more when towards to the end of your, like the criteria, end of your syllabus. Once you have gone through the trigonometry, when you go over the questions, I don't want you to just solve them, but take your time to spend on the reading, and then see if you're able to find a clue, right? So because it's at the end of the day, it's really just the translation test. Really, if they give you a hint, and then are you able to find those hints are what you want to do. Okay, so like the question number 3, this is also a very lovely problem in my opinion, right? So because if you look at this, why this is a lovely problem is the following. Because you can use whatever information you want, so I will do that. But what I want to talk about here is that I need to figure out the cosine D EA. So, and that's not a right angle, is it? So it's going to be cosine 90 degree plus 2x. Oh my god. Then, and yes, you know what? Whenever I see sum of angles like this, maybe you're inclined to use the compound angle. But not for me, if I have some multiple of 90 or 180, because that's really asking you to use either the complementary angle or reference angle. And what do you think, in your opinion here? Yes. Every time I see something of a multiple of 90, it's very tempting to use complementary angle. So I'm going to use complementary angle. So this is the essence of a problem solving. You look at a problem, you find an expression, but you always need to question yourself if you can simplify them using the formulae or theorem that you already have learned in that chapter. And in trigonometry, the very popular one was either the reference angle or complementary angle. So I know that this will become sine 2x. But you need to decide whether it's gonna be positive or negative. Well, I rotated by 90 degree, and I went 2x further. So I landed on the second quadrant, where I know sine must be only positive. So for this one, I'm deriving from the cosine, so it must end up being negative. So that is what I have, right? So that is what I have. And then I have a lovely expression of a sine 2x. So if you can actually find expression of a sine 2x using this information, that's great. If not, no problem, because you know what? I can use the right angle triangle of number 1. So from number 1, I have a tangent x being 1 over 3. Or I can actually use that right angle triangle using the Pythagoras theorem, right? So I've got the 3, 1, and the hypotenuse is going to be what, my friend? A very good, square root of 10. right? That's lovely, because then I can actually find the expression of a sine x degree, and then the cosine x degree. So sine x here is a 1 over root to 10, and cosine x is what? The 3 over root to 10. Then voila, I can actually use those two information to derive the sine 2x using the double angle. Right, so it's really all about the translation. It's really all about the translation. I see the existence of a 19 side of my angle. I want to use a complementary angle. I see multiple of 2. I want to use a double angle. Those things are what the really the high school mathematics is all about. Whether you can decode or you can translate is what they're asking. Oh, wow. Okay, so this is also a very lovely problem. This is a very typical, 3D trigonometry problem, isn't it? So whenever we see this 3D trigonometry, what should be in your blood is that you are willing to use the right angle triangle from the standing. So, by the end of the time you're taking a unit test in school or whatnot, you must be familiar with these type of questions. When we see this type of question for the first time during the test, it will be very difficult, because I know you can do it. I know you are able to solve that, but it will be quite difficult under time pressure. You have to always, whenever you practice, you always have to take into consideration of taking the time pressure. Time factor is the key. So, I don't even have to read the information, because I know I'm going to use this right angle triangle. You see, that's the key. And I know if I have that expression, that this a is going to be expressed as a h over tangent of that angle of elevation and whatnot. This is a very popular form. So let's dig in. So when I look at it, so from the S and N, the angle of depression was 25 and 35, and I can do zigzag, right? So that's gonna be 25 degree here, and it's gonna be 35 degree there, right? And then I got the height of h, which was how much? It was 80 meters. All right, so that's lovely. I got the height. And then please, be willing to use this standing right angle triangle. So if I look at the SX as an A and NX as a B, I can create the tangent. So it's going to be, what is it? The tangent 25 degree is going to be, what is it? 80 over A. So that's lovely, because I can make the A to be 80 over tangent 25. Or, so if you like, you can do the cotangent. Why not? So 80 times cotangent 25 degree. So that's great. So I can do the same thing for part B. I mean, the length B. So if I do that, that's going to be, what is it? 80 times cotangent 35 degrees. So that's great. Okay, so with these, I got the A and B, and then what I have here is that the included angle is going to be 70 degree. So if I look at that triangle on the base, and I got the SXN, and I got A and B, the included angle was a 70 degree. And what are we looking for? We're looking for, what is it? The SN, isn't it? We're looking for the SN. So let's call that as let's say X. That's my aim. And now I'm looking at the SAS case. So when I look at the classification of a triangle, what I need to do is to use, again, the cosine rule. We need to use the cosine rule. And that's it, right? So then, I got all the information here as a constant, so I should be able to solve it. So x squared, is going to be a squared plus b squared minus 2ab. Cosine 70 is going to be the lovely form of this lovely equation for this question. But what I want you to do is not just dive in, but already be relaxed after checking on the question. You realize in your program, you already know, oh, okay, this is going to be 3D. I'm sure it's going to mix with some of the right angle triangle from the standing triangle and use some of the substitution, right? So that's the key. You don't memorize the formula all the time, but you practice more to enhance your translation skills, like that. So when I look at this, this might be more challenging. You know why this is more challenging than the other one? The reason I know that this is more challenging is that this is very short. This is very concise problem where it doesn't reveal too much information, right? So the previous information gave you a whole diagram for us to realize what type of a question that's going to be in a split second. But when I look at this, I don't have much information, and that's challenge. But still, we have to grind on it, right? We still have to manage to find some hints, and especially whenever I see the triangle. So here's the thing, I'm not asking you to classify the types of triangle, because they are all angles. So A it gives you neither cosine rule or sine rule, because they're infinite in many cases. But instead, it's the angles of a triangle. So what comes to your mind at first? Can you tell me that? Very good. What comes to our mind is to actually use the sum of angles of the triangles to be pi. So I'm going to go with the A, B, C being pi. So that's the very first thing I'm going to use. Do you agree? That is great. So I know those are the information. That's the first information I'm going to use. And here's the thing, to show that, it's to prove that. So here's the thing, I can't use the equation right away. Right? I cannot assume to equate them and just like rearrange. I need to choose my side first. You got to choose either left or right. You got to be either sinister or dexterous. And sometimes we can tell which one is evil or not. Okay, it's just all in our... But anyway, so I'm going to go with the left-handed. Okay, so I'm going to go with the left-hand side. Let's be sinister. Why not? And my job is to then use the given information as much as possible. So I know there's some to be pi. And yes, from the trigonometry or trigonometry or triangle, you do know with these pi and then pi minus whatever, really induces the two choices. Either you have to use the reference angle or the complementary angle. And I want to hear from you. What angle do you want? If it's something from the pi or something from 180. You're absolutely right. I'm going to actually attempt to solve this by a reference angle. So let's try. So how I'm going to choose a reference angle is the following. I'm going to go with pi. How should we do? C, let C be, let's say pi minus A plus B. So that's a very great start, because you are grinding to use available option. You see. So let's see. So from this one, I have a same equation of a tangent A plus tangent B, but now I'm letting the tangent C to be tangent pi minus A plus B. So that is great. And it's a reference angle, you see. So I'm just only changing the sign, whether it's a positive or negative. So what are we going to do? We're going to go by pi further, and I'm going to subtract the angle. But here's the thing. You might say, oh, hold on a sec. Can the A plus be acute or obtuse? Yes, you can be either acute or obtuse. But it doesn't change the fact. It doesn't change the form. There's no difference. I mean, you can assume the A plus B to be acute, and it's going to give you the same result in terms of the positive or negative. So I'm going to assume that it's positive. So I'm going to assume that it's acute, and I went pi further, and I subtract by the acute. And which quadrant have I landed on? I landed on in the second quadrant. So that is great, isn't it? So I've landed on the second quadrant. Okay, and let's see what we can do. So it's going to be tangent A plus tangent B, and then because it's the second quadrant for the tangent, I know it needs to be positive or negative. I ask you, you're absolutely right. I gotta make it negative tangent A plus B. Oh wow, that's really nice. Right, very good. But now, okay, now it's more telling. The plot is thickening because now I can use the compound angle because I'm looking at the sum, isn't it? So let's use it. Can you tell me the compound angle? As soon as you flip the page on the formula booklet, you are making a crime. I don't want you to look at the booklet when you are taking a test, when you are taking an exam. That's the way out. I don't want you to have a way out. You must memorize all the formula in your head. So let's go. So it's gonna be, what is it? Tangent A plus tangent B over 1 minus tangent A tangent B. That's lovely, right? So I'm going to then substitute that right there. Okay, that's a very lengthy question, isn't it? So kind of but it's okay, so we can do it. So I'm having a rational form and non-rational form. It's probably the best if you can actually put that in the common denominator. Let's try. So what is it going to be? It's going to be 1 minus tangent A tangent B, and then on the numerator, what would you have? I'm going to multiply by the tangent A, isn't it? So well, I may need the bigger space, so let me go. So like that. So so if I put into common denominator for all of them, right? So it's gonna be tan A minus tan A squared tan B. So that is great. And then for the second part, it's gonna be very similar. Tan B minus tan A tan B squared. Can't be bothered, man, so I'm gonna just use the t for the tangent. All right, please to understand. And then the numerator from the third term to be just tangent A plus tangent B. Oh wow. So let's see if you can make any simplification. Let's try. So when I do the cancellation, I see that I can actually get rid of Oh, sorry. So my bad. It was supposed to be minus tan A plus B, isn't it? So I'm gonna have to subtract here. My bad. Right. So that's gonna be minus minus. Okay, that's better because I can actually cancel things out. Yeah, that's the thing. How I knew there must be something wrong with it here, because after my attempt, this is all about simplification, right? This is all about making reduced things. And if I had that like nasty term like the plus tan A plus tan B, I would have hesitated to answer, because I'm like, oh, hold on a sec. All my attempt is supposed to reduce things and simplify things, but now I'm making things even worse. Maybe I need to stop and check if I've done correctly or to go correct path. Right, that's really the mindset. I don't want you to like just head towards to. You always got to look back and see the river and be happy and solve math. Okay, so let's go. So now I'm gonna simplify tan A, tan B. So that is great. Oh, okay, that's lovely. But now I have a common factor. So let's factorize. So I'm gonna factorize by common factor of a tan A, tan B, and then I'm gonna have, what is it, my friend? Negative. What is it? The multiplication tan A plus tan B over 1 minus tan A tan B. So that is great. But here's the thing. Oh, that looks familiar, because that was actually the simplified version of, what is it? This was a simplified version of minus tan A plus B, which came from the tan pi minus A plus B, which actually came from tan C. So I'm going all the way back, reversely, to actually simplify, to substitute that by just a single term of a tangent C. Okay, so let me just get rid of that and then change it to tangent C. And voila, that's the aim, isn't it? So that is the aim. We started from left and got to the right. Okay, started from the bottom, we're here. Right, so that is what we do. So if it's a proving problem, you need to choose your side. And why have I gone sinister? Because I like being sinister. Because it's always better to start with nastier. Whenever you have a bunch of terms added or subtracted, maybe there's a room for simplification so that you can combine them as a single term by making them as a product or division. So that's how we're going to choose which side we're going to do to simplify whenever we have this identity or proving that problem. Okay. But yeah, it's a great question, you see. Yeah, so I went through the first page, but it's so cold. Maybe I'm gonna go back and continue. But whenever you solve problem with me, what I want you to do is not just like solve the problem right away. Maybe you should solve the problem right away. But if you want to get some clue, I want you to take a lesson that it's important to read. You see, after having the skills of solve the problems, after having skills to compute, right, such as using like double angle, triple angle, compound angle, half angle, whatnot. uh, After acquiring those skills, what you need to do is then to learn English, right? So this is about translation. Can I find the clue? Let's go back. When I look at the SSS case, is it okay for me to use a cosine rule? Maybe it is a good idea. When I look at the multiple of x twice, that's time to use a double angle, even though the question didn't tell me so. Whenever I'm compositing this cosine sine function with something of a 90, I must use a complementary angle. Those translation skill is very important, because if you look at the textbook, the basic or intermediate question they tell you to do, they tell you to convert this and do that. But when you actually see your hard problems, either from the textbook, from the exam, you do realize that you are the one who need to explore those clues, and those are the things you need to really grind on more. If I see this triangle, I know that I've done this so many times that I'm gonna compose it with the right angle triangle. Those are the things you need. When I look at this problem, it's a very concise, and I gotta be prepared, because maybe it's revealing too little. But maybe the very first thing that I would start is that the fact that the angles are add up to pi, and maybe with the pi for the trigonometry, I'm going to use the reference angle. Those type of the reminding skill is what is necessary in our study, in our revision. Okay. Yeah, I do intend to complete this document, but not right now. It's so cold. But yeah, that's it. Yeah, and there are many lovely problems. Let's grind on more, and but that's it. Okay. For the finale of the video, maybe you can enjoy the nice view of a Han River, and enjoy the fresh air. And then I will see you very soon in another setting. See you in a bit.